Hello, in this clip, I wish to go over these three questions, and they were on a written quiz. The first one is to solve for x. Okay, we got two exponential equations. Okay, and number one is 8 minus e raised to the power of 1 minus 4x equals to 20. The second one is to solve an exponential equation e to the power x minus 12 multiply e to the power of negative x minus 1 equals to 0. And the third one, there's a determine, so that's the logarithm. This is a logarithm equation. And this logarithm equation is asking us to determine the domain and then solve for x. And then solve for x, okay? And the equation is log base 2 parentheses x squared minus x minus 2 equals to 2. All right. So start from the first one. The first one, this is a plus actually. Okay. So let me just cover that part. I don't need that. So we have e to the power of 1 minus 4x. We subtract 8 on both sides, so 8 subtracted from 20 is 12. And we apply logarithm definition, so 1 minus 4x equals to natural log of 12. And then we adding 4x on both sides, subtracting ln 12 on both sides. So we get 4x equals to 1 minus ln 12. So here we go. And then we divide it by 4 on both sides. There are a variety of ways. Some of you have 1 on both sides, that's okay. But I don't plan to spend too much time here because I think just algebraic details. If you have any questions, please don't hesitate. You should also get the same answer for sure. Okay. The second one, the second equation, okay, the second equation, there are multiple ways to solve this equation, of course. Okay, so I'm going to use one that was some of the students think is the easiest to view it. So I'm going to use u equals to e to the power x. Okay, then as a result, e to the power of negative x would be 1 over u. Okay. And now, because u is equal to e to the power x, e to the power x is always positive, right? So this equation, after the substitution, we will get u subtracting 12 times 1 over u, subtract 1 equals 0. So u is positive, so we're going to multiply u on every term on both sides. Okay, so on the left side, on the left-hand side, of course, is u times u. On this side, multiply u. On this side, multiply u. On this side, multiply u. Of course, 0 times u is 0. And the next step, you get u squared. And 1 over u times u, that makes 1. And 1 times u is u. 0 times u, of course, that's 0. We got that. And then you just simplify. You just rewrite it in a more familiar quadratic equation form. Minus 12 equals to 0. And after that, you get u minus 4 times u plus 3 equals to 0. By, 0 product property, we get u minus 4 equals to 0, or u plus 3 equals to 0. And consequentially, we got u equals to positive 4, or u equals to negative 3. All right. And then, of course, we're not done yet. Okay, we're not done yet, so make space for it, because u equals to e to the power x, right? So for u equals to 4, we have e to the power x equals to 4, right? That is, oops. So let me just write it. That is u equals to e to the power x equals to 4. And solving for x would be equal to natural log 4. Well, if you like to reduce it, you can, but this is optional because 4 is 2 squared, and that equals to 2 times ln 2. It's optional, okay? For u equals to negative 3, and we got e to the power x equals to negative 3. And of course, this is not possible. Okay, not possible, i.e., there's no solution. So finally, solution is as x equals to ln 4 or 2 times ln 2. Either one of these. Okay, and of course, the latter is optional. So that's it. Other ways of doing it, which we did it in class, right, is not introducing u explicitly. You can do it implicitly. So I just want to mention that, okay? Or, okay, other methods. So you just put the equation out there, right? And if you understood the steps above, you will have understanding of the following step. So the following step, you're gonna have so this is 1 over e to the power of x. So 1 over e to the power x, right? So you're gonna multiply on this equation. You're gonna multiply e to the power x on both sides, right? So that's going to be, you multiply e to the power x on every term. So this is just like multiplying u, right? Multiplying u. And as a consequence, e to the power x times e to the power x, that's e to the power x in parentheses squared. Subtracting 12, right? Because this product makes 1. And subtracting e to the power x and equals to 0, right? So the rest is u was not introduced explicitly, but you can think in terms of this quadratic. So you just shift the term, this commutative property, and then you just do factoring. So you think of u plus 3 times e to the power x minus 4 equals to 0. Okay? E to the power x is always a positive. E to the power x plus 3 is going to be positive. So for this product to be 0, there's only chance is e to the power x minus 4 is 0. Okay, so you can see, so I divided both sides by e to the power x plus 3. So that's going to result in e to the power x minus 4. So in the end, we got e to the power x equals to 4, right? And by definition, x equals to ln 4 or 2 times ln 2. Okay, so that's the two ways of doing it. If the first way helps you see better, great. Okay, the second way, and of course, you can do the second way. And there's also some sidekicks, okay, from here. Okay, some people from here, some people will go say, oh, from here, I'm going to set e to the power x, e to the power x plus 3 equals to 0. Or you can certainly do this, right? You can certainly do this. And you can write e to the power x minus 4 equals to 0. So on this one, this equation has no solution, right? So because e to the power x is always positive, right? Since e to the power x is always positive, e to the power x plus 3 is going to be more positive, right? So that's the first part. And the other part, and you work with, or, and you will get, e to the power x equals to 4, and then x equals to no issues here. So that's it, right? So you can go all these different ways, but you can see the tool used, right? You can see the tool used. Last question. Let's take a look at the last question. Last question asks us to determine the domain. Okay, when determine the domain, we need to know that there's a difference between if I have a question, they ask you, suppose I have a question to ask you to do, say, log base 2 multiply x plus 1 times x minus 2. Suppose I have I have these two questions. Okay, if I ask you to solve this equation, these two equations, right? They look almost like the same, right? Because if you do product rule on this one, right? If you do product on this one, if I factor the log base 2 here, I would have got x plus 1 times x minus 2. Okay, equals to 2. What's the difference between these two equations? Compare with the other, what's the difference? So let me tell you the difference. The difference is that it's the order of operation. Okay, so what is the difference? The difference is the order of operation. Okay, it's the order of operation. On the former one, okay, on the former one, if you look at this, if you look at the order of operation, right? We're talking about input, output. You have an X as input. In the former, you have to do the bracket first. Okay, so we're gonna do the bracket. After the bracket, we do the logarithm. Okay, that's the order of operation. How about the ladder? The ladder is that you have input, right? And so we have this input, we're gonna do x plus 2 first, well, x plus 1 first. So x plus 1 is done. And then we do log base 2 x plus 1. Okay? And at the same time, right, with that input, x, right, we're going to do x minus 2. We're going to do x minus 2. X minus 2, and after x minus 2 is done, we're going to do logarithm base 2 of x minus 2. You can see the order of operation is different. The order of operation is different. All right? So when we are determining domain, when we determine domain, this will be reflected. This will be reflected. So to determine domain, on this one, you need to guarantee the whole of the bracket is positive. Okay, or this whole of it must be positive. Okay, so that's determine domain. That's on the setup. That's on the setup. And secondly, on the second question, right? When we determine the domain, so before we take the logarithm, we need to guarantee that this piece is positive. Okay, and we also have to guarantee, listen to the word, and the ladder has to be positive. All right, so now let's look at the difference. Okay, in domain determination, okay, because when I'm grading the quiz and I found there's a tremendous confusion in the setup. Okay, you may not be thinking of the ladder, the other form, but I want to show you the setup makes a big difference. Okay, so if you were dealing with this question, okay, this ladder question, to solve this inequality, right, you will get x greater than -1 and x is greater than +2. And these two combined, the domain for the ladder function, for the ladder equation would be x greater than 2. Okay? Now, let's look at the first one. Let's look at the one that we have at hand. Okay? So you can see the difference. You can see the difference. On this one, when we factor this, right, we know that it can be factored into this bracket. And I'm solving this inequality. This must be great. Oops, sorry. So this must be greater than 0. I don't need a bracket. Okay, I don't need a bracket. And this inequality does not lead you to that. Okay, what does it lead to? Remember we saw quadratic inequality? Okay, this is a quadratic function. This quadratic function, if you graphed it, it's something like this. There's a picture like this. It's a quadratic curve. It's a quadratic, I'm using the simplest way, which is showing you the graph, okay? And so let me just make a little adjustment to the picture. all right? And horizontally, so I'm going to have -5, just to make it reasonably visually, visibly better. Okay, so that's the curve. That's the curve we're working with. So we're asking the entire curve to be positive. We have worked on these kind of questions, right? So -1, we have x-intercepts, right? So we have -1, 0, and 2, 0. Those are the x-intercepts. So we're going to have these two intercepts marked. Okay, so we're going to mark them on the picture, right? So I'm going to make it a red circle because those points are not included. Second point. And there we go. So these are the 2 points. These are the 2 points, -1, 0. So what are the solutions? The solutions will be less than -1 or greater than 2. So I'm going to mark those points. Okay, you don't have to worry about how to use the software. Okay, so I'm just going to show you. So that's where the solution is. So don't get confused. Don't get confused with the right hand side, you know, the other question. Okay, so this is going to be the picture. There we go. So those points are the solutions. So the solution, which is also the domain for the function, is x less than -1 or x equals to 2. Okay. You can see the differences, right? So let me make it just a little bit, make the fonts smaller so you can see the differences. Okay, here. There we go. So you see the whole of it. You see the whole of it, right? There's differences between these two. But the equation that was given to you, this is the equation that was given to you. This is not the equation given to you. So some of you set up correctly, but fall onto this trap or other traps. Okay, so I don't mean to make this lesson too long, but you know, please come up to me in class so we can have a further discussion. If you are confused, if you're still confused, okay, I hope to make this clear. So after this, the domain is that. This is the domain. Okay, so that's the domain. And this one is a domain for the other. You can see the difference is in the order of operation. So now we're going to solve our former equation. Okay, we're going to solve the equation that we're given, and then we're going to come back to solve the other equation. Okay, so if we solve this equation, right? So we're going to apply, of course, the definition of logarithm. That's going to be that equals to 2 squared. And then of course, that's equals to 4, right? You can condense that into one step. And then that turns into -6 equals to 0. All right. And then you factor. You have x plus 2 times x minus 3 equals to 0. And in the end, you get x plus 2 equals 0 or x minus 3 equals to 0. So and then we got x equals -2 or x equals to 3. If you look at it, if you do the domain check, right? Both numbers are in solution, are in the domain. Both are in the domain. No problem. We have two solutions. So our solutions are x equals to -2 or x equals to 3. We have two solutions. Of course, you can write it this way if you want. There are two solutions. Okay, so let's look at the other equation. The other equation, right? We have done. Of course, this is a different question. This is a different question. Suppose you are given this equation, and we have determined the domain is x greater than 2, right? We're going to solve this equation. We're going to solve this equation. Okay, forgive this math. I'm going to move it down. And then on this piece, we're going to apply product rule. Okay, apply product rule. So we bring them back. And then we're also going to get to that piece. So all of these will apply. Okay, all of these would apply to our solution. Okay. However, in the end, because domain is larger than 2, x equals to -2 is not in the domain. Thus, it is not a solution. So the solution in the end, there's only one solution. There's only one solution. And that solution is x equals 3. Okay? So I'm going to put this side-by-side comparison for you. Okay, let me see if I can do that. Okay? I'm going to put this as side-by-side comparison for you. Let's see, just be patient with me. So as a summary, so here I have two columns, okay? And one equation is like this, okay? So these are two different questions, okay? Don't get me wrong, okay? Don't get me wrong. These are two different questions. And so this is removed. I'm going to put this, I'm going to put this on this side. So these are two different questions. Two different questions. Their domain in the domain we're working with. I'm just talking about the setup, right? So I'm going to add some more rows. Add more rows. 1, 2, 3, 4, 5, 6. Some more rows. Okay. Domain setup. Domain setup. Okay. Domain setup are different. Hold on. Domain setup are different. Okay. So what are domain setup? Domain setup, one is the whole of it equals greater than 0. Okay. That's the domain setup. What's the domain setup for the other one? The domain setup for the other one is this piece. You see, they all agree with the domain requirements for logarithm functions. They must. Okay. It's one is 2 logarithm and the other one is 1 logarithm. And so the domain in the end, after this setup, the domains are, one domain is like this, right? We have gone over it. And the other domain is just according to end, right? The truth table end, we got this. So these two different domains. Solving it, right? Solving it, we all end up in the same place. Okay, solving it, we all end up in the same place. So solve. Okay, so solving it, where actually one applies product rule, okay? So this one, actually, we don't need to do anything. You can just leave it like that. So the other one, you kind of use the product rule. Okay, sorry. The other one, you apply product rule, right? So over here, so you apply the product rule. And the first one, you don't need to apply product rule. Okay, you don't need to apply product rule. You also don't need to do any factoring. And the next step is the next step is a common. So the next step are completely the same. Okay, let me make it fonts larger. Right? You can see the difference. And the solutions are the same. Okay, so solutions are the same. So solutions, but of course you have to do the domain check. You have to do the domain check. Solutions are the same, right? And you do factoring the same. Okay, if you like to do this, right? So factoring are the same. So this is going to be x plus 2 times x minus 3. All of that is the same on both sides, on both questions. So the only difference that separates them is domain check. Okay, domain check. Domain check. Domain check, both are solutions. And on this one, -2 is not in the domain. Only one, oops, only one is in the domain. Okay, so finally the solution. Okay, so let me have a proper closure. Okay, so solution. So the solutions are, right? Solution, boom. So the solution for the first one is that, and the solution for the other one is only x equals to 3. All right, you can see the difference. And when we solve this inequality, okay, of course they're very different. I don't know if some of you thought of this. You use the technique we learned about solving quadratic inequality, guys. Okay, we've done that. All right, so I can see there's some confusions out there. But anyway, without further ado, thank you for watching.